In this video, we're going to talk about how to solve quadratic equations with complex roots using the quadratic formula. So you can use the quadratic formula to solve quadratic equations that are in standard form, which is ax squared plus bx plus c equals 0. So remember, the solutions to a quadratic equation can come in three types. We can have one real solution, two real solutions, or no real solutions, which we can see from the graph. And remember, we can use the quadratic formula to predict the number and type of solutions. And remember, we use this by calculating the discriminant. So the discriminant is equal to that value that's under the square root. So we have that b squared minus 4ac, which is equal to the discriminant that we're calling d. So remember, the discriminant tells us is that if we have a d that is less than 0, so a d value that's negative, the equation will have no real solutions because both solutions will be complex. And that is the situation that we're going to be talking about in this video. So remember also, we want to simplify whenever possible by simplifying the radical and checking whether there's a number that evenly divides every term. So once we plug in a, b, c, and the value of d into our quadratic equation, we can get something that looks like this, for example. We have 4 plus or minus the square root of negative 180 over 2. Remember, whenever we're dealing with a negative square root, we start off by factoring out that negative 1. And the reason we do that is because that square root of negative 1 will turn into I. Remember, whatever's remaining under the square root, we want to think about simplifying that also. So the square root of 180 can turn into the square root of 36 times the square root of 5, which is 6 times the square root of 5. So now we have 4 plus or minus 6i square root of 5 over 2, and what we can do is actually divide every term in this expression by 2. So this will reduce to 2, this will reduce to 3, and then this will just cancel out and become 1. So we have 2 plus or minus 3i times the square root of 5 as our final answer. So remember to always simplify whenever possible. So another thing to remember is that if you have a complex number, a plus bi as the solution to a quadratic equation, its conjugate will also be the solution. So notice that the two solutions to this equation are 2 plus or minus 3i square root of 5. And if we write them out, we have 2 plus 3i times the square root of 5. And 2 minus 3i times the square root of 5. Notice that these two solutions are complex conjugates. So here's how we're going to solve a quadratic with complex solutions using the quadratic formula. We're going to first make sure our equation's in standard form, and then identify the values of a, b, and c. Then we'll calculate the discriminant, and the discriminant will tell us the type and number of solutions. Then we can plug all of these values into the quadratic formula, and then use the product property to factor out a square root of negative 1 from the radical. And then we'll replace that square root of negative 1 with I. Then we'll simplify the remaining square root and rearrange the terms so that the I comes before the square root. Then we'll simplify if there's a number that evenly divides all the terms in the final answer. So let's start off with this example. So this is already in standard form, so I'm going to go ahead and now label the values of A, B, and C. So I have A equals 5, B equals 2, and C equals 1. Let's calculate now the discriminant. So remember, the discriminant is b squared minus 4ac. So that's going to give me d equals 2 squared minus 4 times 5 times 1. So 2 squared is equal to 4. So we have 4 minus 4 times 5 is 20. 20 times 1 is just 20. So we have d equals negative 16. So that is less than 0, so I know that I'm going to have two complex solutions to this quadratic equation. So let's go ahead now and figure out those solutions. So we have x equals negative b, so negative 2, plus or minus the square root of the discriminant, so square root of negative 16, all over 2 times a, which is 2 times 5. So I'm going to work on now fixing this square root, okay? So we have x equals negative 2 plus or minus the square root of 16 times the square root of negative 1 all over 10. Well, the square root of 16 is just 4, right? So we have negative 2 plus or minus 4. And remember that the square root of negative 1 is I, okay? And that's all going to be over 10. Well, notice that now every term in this expression is divisible by 2. So I'm going to go ahead and use that to reduce everything. So this will become a negative 1. This will become a 2, and this denominator will become a 5. So we have x equals negative 1 plus or minus 2i all over 5. Okay, and so those are the solutions to this quadratic equation. So now you can go ahead and pause the video and try doing this example on your own. So this is already in standard form, so we can go ahead and label the values of a, b, and c. So then we can calculate the value of the discriminant, which is negative 144. Since that is less than 0, we know that we'll have two complex solutions. So when we plug into the quadratic formula, we have negative 8, which is positive 8, plus or minus the square root of negative 144. The square root of negative 144 is 12i, so we have 8 plus or minus 12i over 8. Then every term in this expression is divisible by 4, so that will turn into 2 plus or minus 3i over 2. So now let's try this example. So notice that this is already not in standard form, so I'm going to go ahead and put it in standard form by subtracting 13 from both sides. So that's going to give me 3x squared plus 2x plus 5 equals 0. So now I can identify the values of a, b, and c. So I have a equals 3, b equals 2, and c equals 5. So I can now calculate the value of the discriminant, which is b squared, so 2 squared minus 4 times 3 times 5. So we have d equals 4 minus 4 times 3 is 12. 12 times 5 is 60. So we have 4 minus 60, so we have d equals negative 56. So that's less than 0, so we know we are going to have two complex solutions. So let's now plug into the quadratic formula. So we have x equals negative b, so negative 2 plus or minus the square root of negative 56 all over 2 times a, which is 2 times 3. So that's going to give us x equals negative 2 plus or minus the square root of 56 times the square root of negative 1 all over 6. So we have x equals negative 2 plus or minus the square root of 56 can be made better by factoring out the square root of 4. So we have the square root of 4 times the square root of 14, and then that square root of negative 1 will become I. So that's over 6. So we have x equals negative 2 plus or minus 2i times the square root of 14. And that's all over 6. Well, now notice that all of these terms are divisible by 2. So I'm going to go ahead and divide every term by 2. So I have negative 1, 2 cancels, and then we have 3 in the denominator. So this is going to turn into negative 1 plus or minus I times the square root of 14 over 3. And so those are the solutions to our quadratic equation. So now you can go ahead and pause the video and try doing this example on your own. So this quadratic is already in standard form, so what we're going to do is first calculate the discriminant. So the discriminant will be 36 minus 88, which is negative 52. So we plug into the quadratic formula, which gives us 6 plus or minus the square root of negative 52 over 4. We can make the square root of 52 better by factoring out a square root of 4. So that's going to give us 6 plus or minus 2i times the square root of 13 over 4. Notice that every term is divisible by 2, so we're going to get 3 plus or minus I square root of 13 over 2. So the quadratic formula can be used to solve a quadratic equation with complex solutions. Remember to simplify the final answer as much as possible.